Let us turn towards the next topic of the unit first, curvilinear coordinate system. We know that to fix the position of particle we need coordinate system. Generally, we use Cartesian coordinate system to study the different phenomena and behavior of the particle or a system. Sometimes Cartesian coordinate system is not sufficient to solve the problem or to study the phenomena. To study such problems, the spherical polar coordinate system and cylindrical coordinate systems are developed. All these three coordinate systems are obtained by using one general coordinate system that is known as curvilinear coordinate system. Let us P of xyz is the position of particle or a point in Cartesian coordinate system. This position is obtained by intersection of three mutually perpendicular planes, x equal to constant. Let us draw plane x equal to constant. This is a plane cuts the x-axis and parallel to y and z axis, which is known as x equal to constant plane. Then y equal to constant. This is a one plane there y equal to constant. For this plane y coordinate is constant and z equal to constant. This is a plane for which z equal to constant, and we get intersection of these three planes is known as point of intersection. Draw. This is x equal to constant plane. This is y equal to constant plane. This is z equal to constant plane. And intersection of these three will be somewhere here. Okay. That is, the position of point is obtained by intersection of three mutually perpendicular planes, x equal to constant, y equal to constant, and z equal to constant. Now relate these x, y, z coordinates with three new coordinates u1, u2, and u3. We can relate the Cartesian coordinates of the point to the new coordinate system having new coordinates u1, u2, and u3, and therefore we can relate a Cartesian coordinates to these new coordinates x equal to x as a function of u1, u2, and u3, y equal to y as a function of u1, u2, u3, and z equal to z as a function of u1, u2, u3. That is, we can obtain a relation for x in terms of u1, u2, u3. Similarly, you can obtain relation of y in terms of u1, u2, u3, and relation of z in terms of u1, u2, u3. These equations can be solved for coordinates u1, u2, u3 in terms of x, y, z. These equations can be solved for the coordinates, new coordinates u1, u2 and u3. That is, so that we have u1 equal to u1 as a function of x, y, z, u2 equal to u2 as a function of x, y, z, u3 as a function of x, y, z. Means we have first equations for x, y, z in terms of u1, u2, u3, and you can convert these equations for u1, u2 and u3 in terms of x, y, z coordinates. Now each point P of x, y, z in space is associated with a set of coordinates u1, u2 and u3 in new coordinate system. These equations 1 and 2 are known as transformation equations. Transformation equations. What are transformation equations? The equations which relates the two coordinates systems are known as transformation equation. That is, you can express one coordinate system into other coordinate system or vice versa. Let us see the coordinate surfaces, coordinate curves. For each point P in curvilinear coordinate system, the surfaces are passed through that common point P, and these equations can be written as u1 equal to b equal to constant, u2 equal to b equal to constant, u3 equal to c equal to constant. These three represent three different surfaces in curvilinear coordinate system, and these surfaces are known as coordinate surfaces. In general, coordinate surfaces may be curved. These coordinate surfaces intersect with each other, giving three curves. These coordinate surfaces intersect with each other and gives three curves known as coordinate curves. Or lines. On each coordinate surface one coordinate is constant and other two coordinates are variable. The coordinate surfaces and curves of curvilinear coordinate surface are shown in figure. The coordinate surfaces and coordinate curves of curvilinear coordinate system are shown in figure. Let us draw a figure for curvilinear coordinate system. How we can draw curvilinear coordinate system? Okay. Let us draw curvilinear coordinate system. Suppose this is u1 curve. This is u2 curve. And this is u3 curve. Now we have three curves, u1 curve, u2 curve, u3 curve. Then we know intersection of two surfaces gives one curve. Now u1 curve will be intersection of u2 and u3. Here is u3, therefore you have to take here u3. u3 surface here will be u2 surface. That is intersection of u2 surface and u3 surface gives you u1 curve. Similarly, intersection of u3 and u3 and u1 surface gives you u2 curve. Intersection of u2 surface and u1 surface gives u3 curve. Means we have these three curves, u1, u2 and u3 curves, and similarly there are u1, u2, u3 surfaces. Now we want to show the unit vectors in curvilinear coordinate system. Now draw the tangent at a point of intersection of three curves. From that point, draw a tangent to each curve. Now tangent for u1 curve is like this here. That is known as e1 cap. Tangent for u2 curve from this point is e2 cap, and tangent from this to the u3 curve is e3 cap. Means we have three unit vectors. The surface on which u1 is constant is known as u1 surface. Now this is u1 surface. For this surface u1 is constant. I can draw this is surface. Similarly you can draw here. Draw curve parallel to the u1 curve. Draw curves. Then draw again parallel curve to u2 curve here. This is u3 surface on which u3 coordinate is constant. Now draw here again another different surface. It's u2 surface actually. Draw curve parallel to u1 and u3. You will get a shape of surface. Now this is u2 surface on which u2 coordinate is constant. On each curve, one coordinate is variable and other two coordinates are constant. Now see this u1 curve. On this u1 curve, u1 coordinate is varying and other two coordinates are fixed. Therefore, it is known as u1 curve. Similarly, on u2 curve, u2 is variable, other two u3 and u1 are constant. Similarly, on u3 curve, u3 coordinate is variable and other two coordinate u2 and u1 are fixed. This is some basic introduction of curvilinear coordinate system. An intersection of three curves gives you position of point P, or intersection of three surfaces gives you position of point P. Okay. Now let us turn towards the next topic. Length, area and volume element in curvilinear coordinate system. Want to determine length element, area element and volume element in curvilinear coordinate system. Let us draw a small volume, that is infinitesimal volume, in curvilinear coordinate system. Now first draw curvilinear curves. This is U1 curve, U2 curve, U3 curve. Now construct areas first. We have drawn curves, now areas. Draw curve parallel to U2 curve like this. Draw curve parallel to U1 curve like this. Okay. Draw curve parallel to, from this point, parallel to U3 curve. Draw curve parallel to U1 curve. And draw curve parallel to U3 curve here. And draw curve parallel to U2 curve. Then again draw curve parallel to U1 curve. Draw curve parallel to U3 curve. Draw curve parallel to U1 curve. We have constructed here small volume in curvilinear coordinate system. In Cartesian coordinate system, we know small volume element is parallelepiped. When curvilinear coordinate system, we get volume element like this. The length element along U1 is called dl1. The length element along U1 is known as dl1. That is, this is dl1. The length element along U2 is dl2. This is dl2. And length element along U3 is known as dl3. And we can write equations for length elements. First length element is dl1 equal to, not it du1, actually it is h1 du1. dl2 is h2 du2 and dl3 is h3 du3 are length elements. And where h1, h2, h3 are known as scale factors. Then the area elements, we can write the area elements. Which are area elements? We have this area element, we have this area element, and we have this area element. These are three area elements. Actually there are total 6 area elements for this volume element, and opposite area elements are same. Now we want to write area element. First I can construct dl1, that's why dA1, which is area element. dA1 I can construct by using dl2 and dl3. This area element is dA1, dl2, dl3. Now I want to write area element dA2, which is dl1, dl3. Which is dl1, dA3? This is dl1 and dl3. This area element is dA2, and I will write now dA3, third area element, dl1, dl2, which is dl1 and this is dl2. This area element is dA3. These are the area elements. Let us write the volume element. The volume element in curvilinear coordinate system is given by multiplication of three length element dV is equal to dl1, dl2, dl3 is equal to h1 du1 into h2 du2 into h3 du3, and therefore we get h1 h2 h3 du1 du2 du3. This is volume element. That is, multiplication of three length elements is a volume element. Now you can take one area element and corresponding length element. Again you will get volume element, that is dA1 into dl1. You will get h1 du1, h2 du2 and h3 du3. Means we get same equation. Multiplication of corresponding length element and area element also gives rise to volume element. Now let us turn towards next topic.